Hello, so in this video I will give you an introduction to certain functionalities that you can use to get some data about your map sheet to better describe your map and analyze your map using the capabilities of a GIS. And so this is really where you'll see the advantage of using the GIS files of a Surficial geology map sheet rather than just relying on an image of the map, like a PDF version of your map. But I'll just show you some of the basic nuts and bolts of using a GIS to analyze a Surficial geology map sheet. So last time we used the we've been using the Lac La Porte map sheet, and so this was the result of our last tutorial. So we've got the hill shade and then the Surficial map polygons and the striations on it, and we were able to create nice figures with the legend and the scale and so on. But now let's say that okay, so your job now is to describe and analyze your map, and you're interested in, for example, you might be interested in getting some values, some numbers about certain things. For example, you could be interested in knowing what's the average elevation across the map sheet, or the range of elevation. And then you could go further and say, okay, what about specific units? What is the average elevation of areas where bedrock is outcropping on the map? Is it higher? Like, what's the difference between the mean elevation of those bedrock highs and bedrock areas relative to, let's say, the areas of glacial fluvial sediments? So you might want to be able to extract some of that information. So first of all, you've got to bring so let's turn this off for now. You've got to bring the DEM. So if you got the hill shade, hopefully you also downloaded the DEM, the digital elevation model that came with that hill shade. So this is a grid file, okay, or a raster in the language of GIS. This is specific. There are different kinds of grid file formats, and so this is specifically a geotiff, but it's a raster file. So essentially it's a grid. It's got like rows and columns of cells, and each one of them has an elevation value associated to it. So this is the elevation model, and so it gives you all the values based on an elevation model. Now, if you just click on the properties, you'll be able to get some information. For example, you'll get the maximum, which is 704 meters, the mean, the minimum value. So it gives you the standard deviation. That's for the whole raster. Okay, so you've got that information already there that's readily available. Okay, but as I said, you might want to look for specific zones and say, oh, well, what's the average elevation of that area or of that area? And so if you're analyzing a Surficial geology map, you might want to just look at bedrock elevation, as I said before. So let's do that, okay? So in order to extract, you need to create a new shapefile, or at least there are probably several ways of doing this, but this is how I do it. I create a new shapefile from this one, where I just extract the R polygons in this case. So to do this, you find your shapefile. You go into Open Attribute Table. So that's going to open up the table of your map shapefile. And if you remember the U label 1, this is where you've got all of the Surficial unit labels. So you want to select all of the R values. So each row is a polygon of your map, okay? And each of these polygons are classified according to the Surficial geology map legend. So you want to be able to select just the R values. Again, there are different ways of doing this, I'm sure. I use the filter here, where you find the U label 1, you type R, you say case sensitive because there's probably some other R's in the legend, but not uppercase. So you go there and then you click select feature, and then it's selected 747 features. Okay. And so then you can go back to your table and you can double check your results. The R polygons should be all selected. You see, they're all selected, and you can just check whether that's correct. There's, nothing else has been selected. So we're good, and the selection is highlighted in yellow now. And so you can close this, and then you come here, and then you say export, save selected features as, and then you can put a new name. You save it where you want, and then once you've got all that, you can click OK. It's gonna, by default, it will add the saved file to the map, which is what you want in this case. Okay, and so once you've done this, then you should have all of your bedrock outcrops as a new separate shapefile. So now you can use this shapefile and interact with and extract data from the DEM that only overlaps in the XY coordinate with those polygons. So then you can make some calculations, get the mean, get the, all of these things. Now, one thing I noticed is, when you import all these different things like the DEM, the map sheet, you'll have a common coordinate system for your display window here, but the original file may have a different projection. And I noticed that when you use some processing tool, sometimes you run into problems. And when I've tried that the first time, it wasn't working, and that's because my DEM was in a not exactly same projection as the bedrock file. They were all projected correctly on this view window, but stored in the file, the coordinate system was different. So I had to reproject this. And so if you run into the same issue, I'll just show you quickly how to do this. So you have to go in Raster, you go in projections, and then warp, reproject, okay? And then there you can select the input layer, which would be, your DEM, and then you would use the target, which would be the coordinate system you want it to be. So you've got to check your R file, what is the coordinate system of that, and then you want your DEM to be the same. So you make sure that you've got the same target projection system, and then you run this, and it's going to create a temporary reprojected DEM, which you can then save as your new DEM reprojected. And so this is what I did here, okay? And so now I've got both my vector polygon file and my raster digital elevation model file exactly in the same coordinate system. So once you have that, then you can go in processing. There's a toolbox here. You click toolbox, and there is a universe of tools there that you can use for a very wide variety of analysis and overlay, layer, interlayer operations to do whatever you want. So again, we'll do this very simple thing where we go to raster analysis, and then you go to zonal statistics. Double click on that, and then your input layer will be not the full Surficial map, but just the bedrock, because in this case, we want to just get elevation values, elevation data in areas where bedrock is outcropping in our example, okay? And then you select the reprojected, just make sure that you take the right DEM, and then there's only one band in these DEMs, Here you can write an output, prefix, or this is optional. And then these are the statistics to calculate. So you might want to customize this, but generally this is pretty good. So that's going to give you a count. So what is this? Well, this is the count of cells. It's going to give you the value, like how many cells in the DEM, how many cells there are in below each of the polygons in the overlay. So the big polygons will have a large count number, and the small ones will have a small count. So it gives you the number of cells, okay? And then the sum is going to give you the sum of elevation of all of these cells, okay? And then this is going to give you the mean for each of the polygons. So it's not the mean for the entire, for all of the polygons. It's going to give you a mean for each of the polygons. So that's why you want the count and the sum, because then you'll be able to use that to calculate yourself the mean for all of the polygons. Okay, so then you select that, you say, then you're happy with this, and then it's going to again create a temporary file, or you can write a file name and go and save it somewhere if you want, and then it'll be, and then you click run, and it will run this thing. And if everything works, then you should get a new shapefile, which is going to be, again, all of the bedrock outcrop, but the attribute table of this one will contain the statistics. Okay, so count, sum. When I did it, I added the mean, standard deviation, and min, max but again, this is going to give that to you, not for your entire map sheet, but per polygon. Okay, so if you have 747 polygons, then you get a value for each of them. Okay, so then you want to play with this. You can probably do this in QGIS. I personally prefer to take that data and go outside. You can go in Excel, or you can go in Python, or whatever you want to use to analyze your data. But then you can use that. So in order to do this, then it's very simple now. You just right-click on your zonal statistics, and then you select Save Feature As, and then instead of saving it as a shapefile, you can save it as a CSV, or directly like a spreadsheet Excel file, okay? And then essentially that's going to save that. And let's say you bring it into Excel, then you've got your count, sum, etc. So then you know that, okay, these are the counts, this is the sum of elevations. So if I sum these columns and I divide the sum by the count, I'll get the mean elevation for my bedrock unit, right? So you can easily do this at the bottom here. So I get a mean elevation of 531 meters in this case, okay? So that's easy, and then you can do this for, let's say you want to compare the elevation of your bedrock with the elevation of your areas of glacial fluvial sediments, just to show, let's say you want to show that, oh, well, glacial fluvial sediments occur around that in the valleys, and at an average elevation of such and such, and on higher grounds, we mainly have bedrock, and this is on average at about that elevation, right? So, and then you get the minimum, maximum values, all these things. So then it gives you some meaningful results. You get some real data that you can use to better describe and analyze your map, okay? And once again, this is just one example of something you can do in a GIS. Now, there's a large set of possibilities that you can use. You can, if you have multiple rasters, you can do some calculations from one raster to another. There's all kinds of things you can do, but for just like basic analysis, basic description and analysis of your map sheet, this is the kind of things that you can do. Okay, you can also measure. You can get an idea of, for example, like average surface area, what's the proportion of bedrock versus proportion of areas covered by till, things like that. So there's all kinds of things that you can do with the GIS. It's very powerful. So I just wanted to give you one example of some functionalities and capabilities of a GIS to describe and analyze your surficial map. All right. Thank you.